Hello class, my name is Josh Williams. Today we're going to discuss IMAP and DNS. So let's get started. IMAP, or Internet Message Access Protocol, is an email protocol that is used to retrieve information from the email servers. IMAP is very similar to POP3 in that it stores emails on the server that can only be accessed by the intended users. Similarly, IMAP also can be encrypted with secure socket layer or transport secure layer certificates. IMAP copies emails to the client system by default and leaves that email on the server. However, it allows the end user to edit and adjust the message as if it were stored on the local system. So another major function of IMAP is the ability for users to organize emails into different folders. So IMAP has several client applications that notify the end user and organize the message into its corresponding folder. For example, Outlook in Microsoft Office application will mark the message as read or unread depending on if that message was received and authentically received by the endpoint user. To install IMAP on a Windows server, you will need to ensure that you have a mail server application downloaded. You will need to edit the configurations of the current mail server to accept IMAP from the graphical user interface. These configurations can be done in the email internet configuration pane in the email service that you're using. In contrast to that, to install IMAP on Linux, you must first install and configure your mail server. Postfix is the most commonly used open source mail transfer agent to configure your mail server connection, and that is used in the command line. Once you have your mail server and Postfix downloaded, you will want to configure them to allow and listen to IMAP or IMAP Secure as a service. Lastly, for IMAP, be sure to add a rule to allow port 993. This will ensure that only IMAP secured with SSL or TLS certificates will be allowed to transfer data. So continuing on, we can harden IMAP with the following ways: using the TCP/IP port 993 to use the secure socket layer or transport secure layer certificate authentication to secure the protocol. When using the SSL TLS connection, be sure to encrypt the password file of the private key to the SSL certificate. This will ensure that the private key to allow the SSL connection will not be easily compromised. Lastly, most mail servers come pre-installed with login protection disabled. It would be beneficial to enable login protection and apply passwords and cache protection. So DNS, or domain name service, is a large directory of domain names that translates these domains into IP addresses. So sort of like a phone book for the internet. As you can see on the right, this is generally how the domain name service is conducted. Essentially, a URL is the domain name that is sent off to the server. The name is then translated and matched to its corresponding directory. From the directory, the DNS then selects a matching IP address and sends it to your computer. DNS is commonly known to store domain names in the corresponding information like IP addresses, email server records, SSH, fingerprints, and even verification records. So how to install it? So in Windows, installing a DNS through the GUI is a longer uh, but seamlessly easier process. You must first install the Windows DNS server, and then next you create a forward lookup zone, and then you will add a host record in that forward lookup zone. Then you'll configure IIS to attach to that DNS. Whereas in Linux, there's a more manual intervention by inputting commands into the command line and building your lookup zone, the DNS server, and the reverse zone file to map an IP to a name you've configured. In Linux, you'll also need to use the bind tools to configure your pieces of the DNS. So how can we secure it? Use DNS forwarders, which DNS forwarders are DNS servers performing queries on behalf of another DNS server. This offloads traffic from the primary DNS, allowing the mitigation of a denial of service attack. Also, you could configure cache pollution. DNSs are prone to caches being filled with malicious links through fake entries. Most DNSs can be configured to correct this issue. Lastly, you can configure access controls to the DNS server settings. This protects unauthorized users from gaining access to files that could essentially compromise the system's configuration. So in conclusion, IMAP and DNS are important factors of communications for servers. IMAP is used a lot like POP3. However, it allows the end user to edit or adjust the message as if it was stored on the local system, whereas DNS is used as the phone book of the internet. Like we said, it sets the domain name in conjunction to the IP and routes the system to that URL. These systems can both be hardened in a variety of ways. The IMAP would benefit most from encryption of passwords and the connections themselves, whereas DNS would be best by cutting out unnecessary tools and features that are included when enabling some features to better protect the risk of denial of service. So in the same breath, you can enable some features, but also disable the unnecessary ones that are there. So thank you for taking the time to watch this video, and please feel free to leave any additional feedback or hardening suggestions in the D2L section provided by Professor Green. Thanks.